Hey everybody, it's Mr. Carr again. Today we're going to be starting off our Unit 6 with 6.1 Day 1, applying the Pythagorean Theorem. Okay, so a quick reminder, what is the Pythagorean Theorem? If I have a right triangle, and it has to very specifically be a right triangle, then that means the leg squared plus the leg squared is equal to the hypotenuse squared. Okay, so what does that mean in my diagram? Well, legs are what make up the right angle. So A and B are both legs. C is my hypotenuse. So that means when I kind of simplify this a little bit with A, B, and C, it's probably something you've seen like this before. A squared plus B squared is equal to C squared. Okay. And that is our focus today. And that's what we're going to be working with a bunch of times. So applying it right here, we just need to read through carefully. One of my big suggestions, when in doubt, draw it out. Try to draw out what is describing. So a right triangle has a hypotenuse of length 2 root 3. So here's my right triangle, and my hypotenuse is 2 root 3, and one leg with a length of root 3. So I'll make that root 3 right there. What is the length of the other leg? And so we'll just call that x right now. You want to call it a or b, it's fine, but the key is we're going to set up Pythagorean theorem. So if I have leg squared and leg squared, that's going to be the square root of 3 squared plus x squared equals 2 radical 3 squared. Now, I wrote it out this way on purpose. Make sure you put the parentheses around that, because honestly, you could plug this in your calculator and just make that and let that do the work for you. But the square root of 3 squared becomes 3. And we'll leave it as x squared for now. 2 radical 3 squared is going to be 2 times 2 is 4. Radical 3, well, let's write it this way. It'll be 2 times 2 is 4. Radical 3 times radical 3 is 3. So 3 plus x squared is equal to 12. I'm going to subtract the 3 over here, so it's going to be x squared is equal to 9. So I'm subtracting 3 from both sides. Okay, and then I take the square root of both sides. So to undo x squared, we have to take the square root. So x comes out as 3 here. And that's the length that I'm looking for, is that other leg is 3. Okay, a 15-foot ladder leans against a wall. So again, you want to draw this out as a quick diagram. 15-foot ladder looks like this. We're going to assume that the wall is a right angle to the ground. The base of the ladder is 8 feet from the wall. So that's going to go on this side. How far up the wall is the top of the ladder? So that's going to call this H right there. Set up just like we did here. I'm going to take leg squared plus leg squared is equal to hypotenuse squared. So I'm going to find the height that I'm going up here. So we got 64 plus h squared is equal to 225, I believe. Let me just make sure. Yeah, 225. Okay, and then I'm going to subtract 64 to both sides. So h squared is equal to 161. And finally, I take the square root of both sides here. Now, because it's a word problem and it's a real life scenario of a ladder on here, we're going to go ahead and round this off to the nearest tenth of a foot. So that's 1 decimal place. So when I plug that in my calculator, I get the square root of 161. And that comes out to 12.7 feet. Okay. So tenth of a foot is going to be 1 decimal point there. Right here, we want to solve for x. So this is a good one because we have to set this up as it's a good complicated one, but we're going to set it up as a double problem. We're going to start with, we'll call this one side y. We have 36, 39, and y make up a right triangle. So when I do that, I'm going to do 36 squared plus y squared equals 39 squared. Okay, so 36 squared becomes 1,296 plus y squared is equal to 39 squared, which is 1,521. I'm going to subtract the 1,296 to both sides, so that y squared is equal to 225, and then I square root this, so y comes out as 15. Okay, so that is the length of this side right here. The next thing I'm going to do, I'm going to do the big triangle like this. And that's made up of 36, 60, and this side here, which I'll just call it B. So I'm going to do that as its own triangle, because I'm going to do 36 squared plus B squared is equal to 60 squared. Okay, so this is going to be 1296 plus B squared is equal to 60 squared, which is 3,600. I'm going to subtract 1296 over. So that b squared is equal to 3600 minus my 1296. Gives me 2304. And then finally, I'm going to take the square root of both sides. Okay. And that comes out to 48. Now, that is the entire length here, which is 48. And I want to find the length of x. So x is going to equal to 48 minus 15. That's what's left over from between this and this when I compare the two. So if I subtract 48 minus 15, I get 33 for x. Okay, so this is a good example because you noticed all of my square root numbers were perfect squares. All of these numbers are whole number integers here. These are what's called Pythagorean triples. Pythagorean triples are a set of three integers that satisfy the Pythagorean relationship. Okay, so in every case here, let me say this real quick. Our Pythagorean relationship is a squared plus b squared equals c squared. Here's the thing to remember. This is always the longest side. So c is always the longest side. So here are a set of four Pythagorean triples. Notice all the other numbers here are actually just multiples of that. This column, if I multiply by 2, those are all Pythagorean triples as well. Or if I take that and I multiply it by 3, those are still Pythagorean triples. So as long as we have like a basic version, like these first 4 right here, we can always multiply by some other integer, and that will always be a Pythagorean triple as well. All those really do is offer a shortcut. Like, so for example, if I recognized, this one's tough, but 15, 36, and 39, that is, what is that? That's a 5, 12. That's a 5, 12, 39 turns into this one. So 15, 36, 39. It would have made it a little bit quicker, but it's not that you have to memorize these. All right. All right. So next thing I want to do is find the area of our isosceles triangle in this given scenario. The thing to remember, quick reminder about both isosceles triangles as well as the area of a triangle. So the area of a triangle is going to be 1/2 base times height. Okay, so the base is going to look like this, but the height is always perpendicular to the base. So here's an example of an isosceles triangle with two congruent legs like that. The height of this triangle does a couple of things. First off is when I draw the height in, it is perpendicular to the base. It also splits up the base into two equal pieces. So what I get is actually two identical right triangles here and here. So knowing that I can create a right triangle out of this, that's what I'm going to use to find this. An isosceles right triangle has a hypotenuse length of 20. Oh, that's weird. It's a little out of place, but it's fine. So we're going to draw this out. An isosceles right triangle looks like this. Okay, the hypotenuse length is 20. Find the exact length of the legs of the triangle. So because it's an isosceles right triangle, my hypotenuse is 20 like it is in the diagram, both of these sides are going to be the same. So what I can do is I can make it x squared plus x squared is equal to 20 squared. Okay, still Pythagorean theorem, but I'm going to make it x squared and x squared like this. So I put these together, that's 2x squared is equal to 400. When I multiply that out, divide both sides by 2, I get x squared is equal to 200, and then I square root this. So 200 is the same as 100 times 2. So I take the square root of 100 and the square root of 2. That means x is equal to 10 square root of 2 inches. That is my exact length. Remember, with exacts, we need our radical number in there. Okay. Our last thing here. An isosceles triangle has a base measuring 24 meters and its two congruent sides, each measuring 15. So here's my base is 24, my 15 for my both congruent sides. Find the area of the triangle to the nearest square meter. So again, area is 1/2 times base times height. I actually have the base of the triangle here. It's going to be 24. But my height is this height when I draw it in like that. So when I draw this in, I suggest drawing it like this. It's its own separate right triangle right here to the side. So 15 is still right here. 24 gets split in half, so it's going to be a 12 here. And that's going to be my h right there. Well, this is where Pythagorean triples are handy. I can go ahead and do this as h squared plus 12 squared equals 15 squared. But if you recognize the Pythagorean triple here, it's a 9, 12, 15. Okay, it's a 3, 4, 5 multiplied by 3. So as a shortcut, I know that h is just going to be 9, 9, 12, 15 here. Makes it a little bit quicker if I recognize my Pythagorean triples. Now I have enough for my area. Area is equal to 1/2 times the base 24 times the height of 9. So I just multiply these three numbers together. So that is 1/2 times 24 times 9 gives me 108 square meters in this case. Okay. So we had a variety of examples here. Everything, though, if I summarize today, we're just applying the Pythagorean theorem in multiple ways. Okay, so remember, Pythagorean theorem, it's a leg squared plus leg squared equals hypotenuse squared when you have a right triangle. Hypotenuse is always the longest side. We shorthand that with a squared plus b squared equals c squared, but these other examples are all just based on that and just finding these right triangles and how to apply them in this case. All right, but that's it for 6.1 day one. All right, I'll take care and see you in the next one.